speak in front of my mentors and stalwarts in the field of pediatric cardiology. My topic is about a range of devices to close the VSD. I'm mainly talking about the new MemoPath VSD occluders. My sincere thanks to Dr. Ramya ma'am, who is a senior colleague. We both together do all the cases in our department. So mainly talking about this medical background of this various VSD occluders, and I'll illustrate each occluders with some examples and literature and with some of our experience in our own cath lab. So I'm not going, due to shortage of time, I'm not going to detail about these types of VSDs because all the people aware about the VSDs. So what is the ideal VSD device? Should abolish the shunt without any significant residual, and there should not be any disturbances in the aortic and tricuspid valve, and most importantly, there is no disturbances should be in the conduction system. Because this is the one problem we have to address in the long-term thing and all. Recently, we heard about the talk of Bharat Dalvi sir. The patient post-VSD device came with the left bundle bench block. So this is the one area we have to address when we are closing the perimembranous or any other type of VSDs. So wide range of available devices, especially in Asia, include a single disc device which has a less clamping force, or coils. Unfortunately, coils is not available in India, and there are a lot of double disc device is available. So how to choose one device from the another? So what about the VSDs? Is it proximal to the aortic annulus? Are we going to cause some aortic regurgitation? Is it relation to the tricuspid valve, long-term development of mild to moderate TR? It's not good for the patient. And how many exits? Is a multi-fenestrated VSD or a single VSD? And basic important thing is size of the VSD. So perimembranous VSD, there are 4 types. So I'm just going in the example. This is the area exactly in the perimembranous VSD, and unfortunately it is always sitting to the next to the AV node. And as we know, every patient's AV node is not in the common place, and that's a reason we need a customization of device. So this is the relation to for the perimembranous VSD with the conduction system, and this is the first type A VSD where absolutely there is no aortic rim, and this is type A VSD, and this is situated just below the aortic valve. And type B perimembranous VSD, there always a thick supraventricular crust, and which will separate the aortic valve, and it will always have a good margin to close with any type of devices. So this is the arrow shows that thick supraventricular crust where below the VSD is located, and this is the most common type of VSD in our location. This membranous, there will be a septal aneurysm will be present, and which will be formed by the fibrous ingrowth in the edge of the defect. And another type D, which is like another common thing, there will be aneurysm. It will be partially closed by this septal tricuspid leaflet aneurysm. So this is also the various types of VSDs we will be able to see in our practice. So coming to the zero aortic rim, zero aortic rim, as I said, just below the aortic valve, where we can use the whole eccentric device needed. Unfortunately, the ambulance has withdrawn this that eccentric asymmetric device. And if there is a good muscular margin, as I showed in the type B thing, we can use either a ADO1 or muscular device. Whereas the membranous septal aneurysm, which formed by the fibrous tissue or septal tricuspid, if ADO2 is less than 6 millimeter, everyone uses this thing. And MFO is a versatile device which is more than 6 millimeter we can use, and multiple ADO2 or 2 to 3 MFOs if multiple exits is there. And aneurysm, we can either use a ADO1 or ADO2. So this is the most conventional practice which we design. So why do we need the customization in case of VSDs? Because we have a different sizes of the defect, and there are different types of perimembranous VSD, because perimembranous VSD is not a one category. As I showed 4 types of VSD, and we have to cater because of the thickness of the interventricular septum, because this reduces the clamp force as much as possible, and the radial force to reduce the radial force as much as possible, because with maintaining early closure capability. So talk about this MemoPath VSD occluders. There are a lot of implants recently, around more than 1 lakh implants around the world, and it is little new to subcontinent, and this titanium oxide coating prevents the nickel leaching, and the studies prove the improved biocompatibility, and the shorter hub is there for quicker endothelialization. So this is the problems I was mentioned. Many VSD occluders have a 3rd degree AV block because of the compression force of the occluder, and especially is very impacting the young patients. So this company has come with some solutions of size of there is a different waist length sizes. Like for example, muscular VSD have different waist length sizes, as well as the membranous symmetric also having from 3.5 to 5, and asymmetric also is a different waist length sizes. So this is first muscular VSD occluder. As I mentioned, the VSD defect is up to 3 to 4. We can use +1. We can oversize by +1, and 5 to 16. We can oversize by +1 to 2. And the waist length is from 5, 7, and 10, which can be depending upon the interventricular septal thickness. And again, next is a membranous symmetric VSD occluders. This also comes in a different waist length. 4 millimeter have a 3.5, and 4 to 8 have a 4 millimeter waist length. So they comes with a different waist length to reduce the clamp force as much as possible. This is the one membranous asymmetric VSD occluder, which has a larger LV disc compared to the RV disc. This is very good for the multi-fenestrated VSD occluders. I will tell each and every VSD occluders with some examples. So this is already mentioned about the membranous perimembranous VSD with aneurysm. This is a one zero ring eccentric VSD occluders. This is for use for the type A perimembranous VSD, where the VSD is located just below the aortic valve, and because of the platinum markers towards the LV side away from the aortic valve, this will never impinge on the aortic valve. So this is a pictorial diagram for the defect close to the aortic valve. You can place the defect, this platinum markers towards this thing, and this there is no rim towards the thing. It avoids friction to the aortic valve, and even the less than 2 millimeter aortic valve distance also can be placed, and off-centered hub provides a clear direction under the chest X-ray. So coming to the 4 different models, we'll go with each and every model with some examples. So this is a 9-month-old child, 5.2 kg, and moderate size VSD antifailure therapy, and recurrent LRTI, and the diagnosis is almost a large 7 millimeter perimembranous VSD with aneurysmal septum, and this is a chest X-ray and LV volume overload pattern, and this is a echocardiography showed there is a large 7 millimeter perimembranous VSD with aneurysmal septum, almost like a type B VSD, and we need to occlude the device. The child is only 5.2 kg and 7-month-old child, and we decided to choose 8 millimeter membranous VSD occluder with a customized gap of 5 millimeter so that to avoid the clamp force. And this went to the antegrade since advantages of every center has doing the RV crossing. So we no more this AV loop formation is there. So the time is also not much difference. This is a LV angiogram showed this thing and all. Ideally, this is prepared for the case in the box session. So just show the. So this is a membranous VSD, 8 millimeter VSD we are loading, and the double disc device. So from antegrade route, we are this thing post VSD device angiogram showed a good result and not much residual. So echocardiography in the follow-up showed there is a trivial TR which is almost in the pre-procedure. Definitely there is no aortic regurgitation, and the VSD device in position, and there is no residual flow. So this is a child of 5.2 kg now, almost gained 8 kg in a span of 4 months. So another example, this is a perimembranous VSD. As we know, restrictive perimembranous VSD continues to have a LV volume overload pattern. We decided to go for the, it's a typical membranous VSD. We want to 3 millimeter waist, from 3 millimeter to 5.5 millimeter waist length is available. ADO1 is option, but we have to oversize by 8.6 or 10.8 for a 5 millimeter VSD. So we decided to go with 6 millimeter VSD device because we had a 5 millimeter, we measured with a 5 millimeter. So this is a 6 millimeter membranous symmetric VSD occluder to have a reduced radial force, and we are not much oversized also, and it's a double disc, so our position is also secured. So this is the final result, the VSD in position and no aortic regurgitation or no TR. So this is about the asymmetric VSD. This is a one patient with a view of pansystolic murmur. There's a large perimembranous VSD with aneurysmal pouch with multiple fenestration. Largest central defect measures 6 millimeter with multiple tiny fenestration. So this is the multi-fenestrated VSD, and we thought initially 2 ADO2s or 2 MFOs. We need to close with the, this is a typical pictorial diagram of multi-fenestration. And we thought we're going to choose this asymmetric fenestrated occluder which have a LV side most thing, so that we can close almost all the holes. So this is the LV angiogram. There is a multiple fenestration just below the aortic valve also with some separation. RV crossing done fortunately, this we can cause any defect, any smaller defect also, because we are going to put a VSD occluder with larger disc on the LV side, and we just kept a buddy wire for the recrossing thing. And this 8 millimeter asymmetric VSD occluder, which has a disc size of 16 millimeter on the LV side, that was deployed. And you can see 16. You can see the LV disc is on the bigger. LV disc is bigger side compared to RV disc. And this is the post echocardiogram. Mild TR, which was pre-procedure, was there. There's no much increase in the tricuspid regurgitation, and VSD device in position, and LV disc is the bigger side, and almost we able to close all the fenestration setting. So coming to the zero rim membranous devices, so this just below the aortic valve, there is no aortic margin at all. Unfortunately, ampullars of perimembranous asymmetric device now withdrawn, and LifeTech eccentric VSD device is there. So we decide to use this zero rim Mevapart device. These devices are positioned in such way that its platinum marker faces towards the apex of the LV, and it should be properly aligned with the aortic annulus. And devices with a symmetric LV retention skid will protrude into the aortic leaflet. So the zero rim, this is just below the aortic leaflets. So unfortunately, it's not playing. So this below the aortic leaflets towards a platinum marker is below the thing, and it is not pinching in the aortic wall. So this also has an option of 3 millimeter, 3.5, and 4.5 to 5 millimeter waist thickness. The last, coming to the muscular VSD device, this is a one patient with the perimembranous VSD with the muscular extension, and 5 millimeter diameter it measured. Septum is 5 millimeter thick. So we chose only 6 millimeter muscular VSD device, and this comes as a 7 millimeter waist between the disc. So to reduce the clamp force for the muscular VSD. So this is a final deployment, and there will be 7 millimeter disc between the discs, ensure there is no clamp at all. So this is a post VSD, this thing, no aortic regurgitation and no tricuspid regurgitation, the VSD device in position. You can see the waist length, the disc separation also. So there was a lot of literature from the from Chinese population, transcatheter closure of perimembranous with and the intracrustal VSD with the zero rim VSD occluders. They concluded there's a selected patients we can use this type of devices, and in experienced hand, the zero rim is particularly helpful in the patients with no separation from the aortic leaflets. And for the hybrid periventricular closure of VSD results in less than 1 year of age, again from Chinese population, and they have proved it is safety and efficacy in less than 1 year of age. And this is a symmetric VSD occluder, transcatheter closure of perimembranous VSD defect using a modified double disc occluders, and there's a multicentric study and 96.6% immediate success rate. There's a zero residual shunt in the 2 years follow-up. Another study of this is having a largest population. 729 cases of Mevapart VSD occluders was deployed, and almost 3 years follow-up, and only one case of complete AV block was required a pacemaker implantation, and they documented this thing. This is our small data started from 2019 amidst of this COVID pandemic. We selectively more than equal to 6 millimeter. We almost 34 patients with large perimembranous VSD. We are subjected to this symmetric membranous VSD occluders, and all have been followed up. And mean age of patients was 26 months, and mean weight was 13.4 kg, and 25% had a large perimembranous VSD with inlet extension, and mean defect diameter was almost 7.5, and QPQS was more than 2:1, and device diameter ranged from 7 to 16, and mainly we used 8 to 9 millimeter symmetric membranous VSD occluder, and fortunately no morbidity or mortality, and closure rate was highest 97%, and we are regularly almost every 6 months we have done the ECG. No freedom from AV block was 100%. One patient had a minimal residual shunt which was still remain unchanged, and the 3 patients had a trivial AR, and 6 patients had a mild TR. Which did not worsen on the follow-up. There was no other device-related complications like a device migrations or others. So to conclude, we have used all 4 models of Mevapart, this VSD occluders, This is very early stage in Indian subcontinent. We need a large scale study with larger population, and to test this hypothesis, there is some merit in this product, as device looks versatile due to lots of customization, various designs, various waist lengths. So are we really going into the customization of VST devices in the future days is still to be answered, and multiple study and large scale study is essential to conclude the hypothesis. Thank you.